I'm CK. Tonight we've got a kit from a new-to-me kit maker, Whadda, out of Belgium. This one is their voice changer, a little voice changing module. I'm sure it's got probably an op amp and a little DSP circuit in it. That'll be fun, and we'll see how their instructions are. We'll see how easy it is to put together and what we can learn from it. I've also purchased a couple of more kits from them just to get a sense for their kit sensibilities, so you'll see them over the next few weeks, and I hope you enjoy the video. Here's the box. It's got an outer sleeve that identifies the product and a standard brown box. I'm gonna take the sleeve off it so we can take a look. Yeah, I think this is just a generic box that they sleeve with whatever kit they want to put on it. Learn how to solder electronics. It's got a little sound indicator, soldering, and it's a level 2 soldering kit. I hope I can do it. French, Dutch, German, and Spanish instructions are available. Make your voice sound like a robot or other odd beast. Vibrato, pitch button, built-in mic, speaker needed, not included. I'm going to use this crappy speaker I got from something else. 9-volt battery not included, and a soldering kit. And on the back, it shows a list of the parts, a QR code for the build instructions. Product is meant for educational or experimental purposes only. Designed and produced by Velleman Group, NV, out of Belgium, as I said before. And it's got all the standard certifications. Premium Makers brand by Velleman. There we go. So again, I have never done a Whadda kit, and I'm looking forward to it, because it looks like they have quite a few, and I can keep busy doing that, can I? Little pull tear to open that up. But it doesn't really open it. Kind of opens it. Oh, it opens that way. Have a little bag. And here we have a piece of paper. Soldering tips, how to put all the resistors on, Zener diodes, push buttons, IC sockets, slide switch, LEDs, a trimmer, and capacitors, PCB tabs. I think that's what we're going to hook the speaker up to when we get to it. Microphone, electrolytics, vertical trimmer, then the connection, and okay, we've got the 2 chips. Where did my pointy thing go? Oh, it went over here. We've got an HT8950, which I believe would be the DSP chip, and an LM386, which is an op amp. So we do have a schematic. It's a little small, but I'm sure if we go to the website, we'll be able to get bigger. It takes 9 volt. It's a switch, grounding cap, current limiting resistor for the LED, Zener diode, cap, microphone going there, ground, and then where's the mic going? It is going in there, okay. Then there's a sensitivity adjustment. That's what one of the trimmers is for. And then there's a lamp coming out of this chip. So this may be... No. Okay. So it's got 2 oscillators, vibrato, and some other abbreviations that I don't know. I can't figure out right off the top of my head. Then here's a little amp stage with the volume trimmer. And here's the 386 op amp. Well laid out. That's a good way to present it on the schematic for people who are not as familiar. If you're just learning about op amps or something, this is a good schematic. I like it. Again, it's a little small right here, but I'm sure if we go to their website, it will be full size and great. And then the speaker is 4 to 8 ohms. I've got an 8 ohm speaker, a 4 ohm speaker here. So I looked on their website earlier and it said 1.5 watt. That's a really low wattage speaker. I don't have any of those. This is a 3 watt. It'll work. And all the, for European Union residents, environmental impact information. Let's look in the bag, get my scissors because I can't open bags. If you've watched me at all, you know I'm terrible about opening packaging because I'm an idiot. So we've got snap clip for 9-volt battery, 1 trimmer. The posts they referred to, oh, these are interesting resistors. I don't know who makes these. These are, the body color is almost orange. It's beige with a little red in it. It's a funny color. I haven't seen that before. And they're the 2 chips and our sockets and caps. And here's the microphone. It's a nice one. Oh, and it's got a little tab, so we don't have to fuss about the polarity. We'll get it right automatically, I hope. Now, one thing you may notice, that I'm certainly noticing, is oh, there it is. I didn't know where the circuit board was. This is a, I'll be polite, this is a inexpensive circuit board. No through-hole plating, just a basic copper mask, single layer. Now the values are not listed on the board, so we will have to refer to the build guide as we put this together, except for the diodes, which obviously we can figure out. Good indication of polarity on the capacitors. Good indication of where the notch goes on the 2 integrated circuits. And that's what we've got. So I'll get the soldering iron heated up and we'll put this thing together. I went to their website and pulled down the build guide, and as I suspected, it's the same as this, just simply in PDF form. So we'll go ahead and use the paper version just because it's easier for me to move it around if and when it gets in the way. The other thing I did was, since this is a lower end circuit board, I washed the back with isopropyl alcohol just to make sure there wasn't any residual grease or other material on here. It does have a Velleman branding on the back. That's kind of interesting that they're branding the board as Velleman while they brand the box as Whadda. And again, premium maker brand by Velleman. So I guess they just want to brand everything any old way they can. Now we'll put a couple of resistors on first. Wow, we've got all the languages here, so you can learn your resistor band colors in all kinds of languages, which is kind of fun. So we'll do the 330 ohm. We'll do 2 of those just to see how the board takes solder. Yeah, see, I'm not familiar with this resistor manufacturer, and this body color makes it a little bit hard to tell the resistor band colors, but that's a minor inconvenience. I'm just being picky. So this is resistor 1 and resistor 2. First thing we'll figure out is how close or far away from the body we want to bend the leads to make sure it's a nice fit. So it looks like we want about 1.5 millimeters away from the body. You don't want to push them right up against the body. Just a nice gentle bend. So this will be R1 and R2. And if you're just getting started on electronics, just one little hint that I do, you don't have to do this. I always put the value bands on a resistor with the highest one going up or to the left, and the lowest thing, the tolerance band, is down or to the right. That's just so later on, if I'm troubleshooting a board or wondering where I might have put something, I can glance at the board and figure out the values immediately without saying, oh, is it brown, orange, orange, or orange, brown, brown, or whatever. Just knowing that I always put my bands with the highest left and up. Now, let's see how this board takes solder. Yeah, pretty good. The holes are a little big. Wow. The holes are really big. I mean, the solder's, you have to really put a lot of solder on here to... This is not... I'm sorry, this is not taking solder at all well. I'm surprised. I mean, it's like the board is taking the solder okay, but the resistor wire is resisting the solder. I mean, look at that. It's not even adhering. That's very strange. I mean, I can pull this right back out already. I mean, I really don't know what's going on there. I'm going to go pause the cameras for a bit, and I'm going to clean these leads off and see if that's a problem. Okay, we'll try this again. I gave the leads a good scrub off with isopropyl alcohol. I'll grab a different piece of solder, who knows? Even though they're both off the same reel. Come on, guys. Okay, that made it go. So there's something on these resistor leads that is resisting the solder. I have not encountered that before. I'm going to try this other one without cleaning it and just holding the heat on a little longer. Okay, that went on okay. Okay, that went on okay. I'm not sure what was up with that first one, but they're all on now. Those two are on now. Now I'm going to do the rest of the resistors. There's not much to talk about with that, so what I typically do on my channel is turn off the commentary and put the playback in fast motion so you can see the resistors just flying on the board. And while I'm doing that, I'm going to be listening to WQXR Classical Radio out of New York on their iPad app, and this is Saint-Saëns Violin Concerto No. 3 in B minor. You won't hear it, but I will. Enjoy resistor time. So that's all the resistors on the board. Pretty straightforward, except having to be careful and globbing enough solder on there so they don't do that disconnected ring. Part of the challenge is simply because these holes, the lead holes, are very big, and the solder has to jump over them. So now we'll put this diode on. Black stripe goes to the white stripe on the circuit board. Now we'll put we'll put all the push button switches on that set the varying characteristics of the voice change that you'll be doing. That's it. 1, 2, 3, 4. Where's the fourth one? There it is. Now these push buttons are not square, they're rectangular. That allows you to put them, not worry about how they go on, because they only go on comfortably one way. If you try and put them on that way, for example, the holes don't line up. You could force it, but if you don't force it, they're in just perfectly. And these are very common switches. You'll run into these all the time. I'm going to do a couple more things. I guess I'll go ahead and solder these while I'm here, because the next step will take a little bit more time. Now, one thing to notice here, which is kind of fun, is besides the schematic, you can also follow the traces. So this switch right here, which says robot, goes here, and that goes to this pin on the DSP chip, on the signal processing chip. So you can learn how everything's laid out and see how it works. That's pretty neat. I'm glad the circuit traces are so big. That's one thing about a single layer board. It's a lot easier to follow what's going on. Now we'll put the sockets on. IC socket, there's the notch. There's the notch indicated on the circuit board. The way I do these is I will put it through the holes, take my soldering iron and solder one leg, let it cool. I'll pick it up, take a look at it. Yep, it's all flat to the board. I'm going to do both. Another way you may want to do it, and you can put your IC socket on the board. And get a little piece of blue painter's tape and hold it in place so you can solder if you want. You can also, another thing I strongly recommend you get for yourself is a good set of tweezers, including locking tweezers, because if you have some good locking tweezers, you can also do that. Let me grab a better one. You can just clamp it to the board like that, and that'll hold it stable and steady for you also. So that's 3 different ways of being able of holding a socket still while you solder one leg, because once you've got one leg done, you're pretty much, you can get rid of whatever is holding it together. I am going to double check. Yeah, that's all flat. Now I'll solder all the socket legs. And there's the sockets. I've got to recycle my cameras because they time out if I don't turn them on and off every now and again. Something I forgot to mention, and I should mention this, on their website they also have photographs of the finished product, which is always good. When you get done, you want to just compare, make sure you've got the bits in the places that the picture shows bits should be. Now I'll do the slide switch. This is the power switch. And the same thing, I'm going to hold this on the board, this time with my middle finger. Do one leg, and I know it's not flat right now, because I can feel that it's not flat. So what I'm going to do is I'm going to see that's a little uneven. I'm going to pick it up. I'm going to press firmly with my index finger on it and my thumb on the board, and I'm going to reheat that little piece of solder, and it lays down flat. That's why I always do one leg first and then do the rest of them so I can make sure I've got it flat on the board. There's the switch. Now we're going to do the LEDs. I think they're both the same color. And I'll show you another little thing if you haven't watched my channel before. If you want to check LEDs, so take your meter. I'm sure you have a multimeter, or hopefully you have a multimeter. If you don't, you will definitely want one as your work goes on and play goes on. So we'll set the multimeter to continuity mode, which means it will beep when there's continuity. What that means is that there is current flowing through the probes. So we can use that with the LED. I have the negative side connected to my black lead from my meter, and then I touch the positive side, and look at that. You can see the LED lighting up. You can do that to test the LEDs, see what color they are, see whatever else you want to know about them. And some people like to test all their LEDs before they put them on, because LEDs do have a failure rate that's higher than, say, resistors, but I generally don't. So on this board, you can see there's a shaded hole that's got a flat side. That's where the negative or cathode lead on the LED goes. And where's the other one, guys? So there's one for power and one for modulation. Ah, there's the modulation one. It's hiding over here. Yeah, always make sure you obviously get the polarity right on the LEDs or they won't work. And then you'll be wondering what's going on. What do we have next? Now we want to do the trimmer. This one will be setting microphone sensitivity. That's the horizontal one here. And let's see if it, yeah, and it's labeled as mix sense. It's also the only location on the board this could take a component like that, so pretty easy to figure out where it goes. And now we'll do the capacitors. Oh, by the way, look at that, I got the LEDs a little crooked, so I'm going to, again, same thing as I would do with the sockets, but this time I'm just going to, or other things, I'm just going to heat both leads up. And I didn't straighten it up because I didn't do the right thing. There we go, and that's all straightened up now. Now, what is it? What was it then? Capacitors, we've got, should have 3 104s, which are 1/10 of a microfarad. And bless my eyes, I cannot read. Oh, we have 4 of them, and I cannot read. Yeah, these are all 104s. So that's 1/10 of a microfarad, or 100 nanofarad. What I like to do is I just clip them right off this tape. I don't try and fight with the tape, the assembly tape, the machine tape. I'll just cut them right off. Now these go in, see, 1, 2, 3, and 4. Now these are generally, I think that's what they're going to be here. I'm looking at the traces now. These little capacitors smooth out the power. If there are any fluctuations, if there's any noise in the circuit or whatever, these work to buffer that a little bit by caching a little bit of overpower If you get a little bit of a power spike or voltage spike, they will absorb that, and then if there's a little voltage drain that goes below the operating voltage, it'll release the voltage it has stored and maintain a good steady voltage for you. You'll see these if you do circuits with integrated circuits on them, you will almost always find a number of 104 caps, the 100 nanofarad caps, on the circuit board to ensure that the chip gets good voltage all the time. Same as if you ever open a package of a kit and you see a whole bunch of 104s and you're wondering where they may go. Well, look close to the integrated circuit, because the closer they are to the chip, the better they filter, because then they're you can look it up. Just look up decoupling capacitor, and you'll find some good articles or YouTube videos about what they are, how they work, and why they're in the circuit. Now we're going to use these little posts, and we're going to put them here for power connection, and then we'll put them over here for our speaker connection. And there's our little posts. Now we'll put the microphone on, and as I mentioned, microphones are usually polarized. One of these pins is positive, one is negative. They're often labeled. This one is not, because it's got this tab with a corresponding slot in the circuit board, so you can only install the microphone one way. I mean, again, without forcing it. If you wanted to force it, you could do it the other way, the wrong way, but you don't want to do that. And now we'll do the electrolytic capacitors, and these are polarized. And with electrolytic caps, just like with diodes, the long leg is positive, short leg is negative. Capacitors also have a stripe and often a negative sign on the negative lead, because nobody wants you to make a mistake. This is the 22 micro, and that goes C5. Now the electrolytics are on. Now, as you can tell, I mean, it should be obvious, electrolytics can retain a lot more power than these smaller 104s. So now we'll put the vertical trimmer on. And now we will put this little, I have an extra cap. Why do I have an extra cap? That's the 10 microfarad. Yes, it is. I'm sorry, folks, I missed a cap. Just get that in there real quick. And put this little knob through the vertical vertical trimmer, if I can do it without breaking stuff. I probably should have done this before I soldered on the board, but there we go. Now I'm going to put the chips in. No, first I'm going to go ahead and solder the power lead on. So I have some special wire bending pliers here. You don't need to use them. If you have some needle nose pliers, they work just as well. And you definitely need needle nose pliers. So the red lead will go on the red terminal. The red lead will go on the positive terminal, I should have said. And on the circuit board it's marked with a plus sign. I'm just going to use these pieces of wire because I don't actually want to solder my speaker onto the circuit board. So I'm going to show you what I did again. I didn't talk about what I did here. So what I'm doing is I'm putting solder on the post, kind of a glob of it on the post, and then I'm bringing my wire around and I'm going to heat the solder up with my iron, and see, the wire just sinks right into it, giving a good connection. And you don't have to fight with the wire and the solder at the same time, because that can be a little bit frustrating. So that is now all the mechanical assembly. I can turn my soldering iron off, but I won't, because I am going to connect the speaker to that with a little dab of solder when we get to there. Now we're going to put the chips in, and I'm going to bend the legs inward a little bit against the side of my workbench. And there's the notch in the chip, and there is the notch on the socket. So notches go with notches, and we press that on in there. Then we take a look, make sure we haven't bent any pins. Do it with the signal processing chip now. Speaker on, just kind of haphazardly. I actually changed my mind. I was going to just connect it like that, but I'm not going to. I'm going to put a longer wire on my speaker because I've needed to do this for a while, because I keep trimming that wire shorter and shorter. So we'll take the green wire, which is going to my negative pole on the speaker, and connect it to this wire, both of which have been tinned. For the sound switch, folks, I had my microphone in my pocket, so we were just hearing from the top camera. Now we've got both. Now we're just about ready to turn this on and see how it sounds. But I'm going to do one further thing. I'm going to take my handy-dandy index card, and I'm going to look at the back of the board, the solder side, and look at each solder connection. And I use the card to make sure I'm only looking at one line at a time and not overwhelming my brain. Make sure all the solder joints are good. Make sure nothing has bled over into something else. That one could be touched up a little bit, but I don't think I need to. I may as well, since I'm looking at it. I think I just need to reheat this one a little bit. Oh, maybe I'll give you a little more solder. Okay. There we go. I don't think that would have made a functional difference, but who knows. Now I'm going to plug the battery in. We'll see what position the switch is in. Okay, the switch is not in a bad position. I'm going to turn this light off. Now we'll switch it on. Okay, it's making a little noise. Now also, I just noticed this. It'll feed back quite a bit. I'm glad I've got a longer cord on it. So I'm going to put the microphone over near the speaker. I'm going to speak into it. This is what I see. The is the bottleneck. This is the throttle. Sounds the same as robot speech, actually. Pitch up. Pitch up. Pitch up. Pitch up. Pitch up. A little bit up. I'm turning the volume up a little bit. I'll go pitch down now. Pitch down. Pitch down. Pitch down. Pitch down. Pitch down. That works pretty well. I'm gonna go back to robot. This is the robot speaking to you. Hello. Hello. We are the robots. Hope I don't get a copyright strike for that. That's a crap song. I think it was too short. And you can't see it because I got my face close to the microphone, but the mod light, LED lights up. I just changed it. I'm going pitch up. Pitch up? Pitch up. Oh, seems to circle around. Seems to circle around. Alright. I'm going to turn this back off. I'm going to turn it back on the robot so you can hear it in the background. So that's what this does. It's a fun little kit. As you can see, it was pretty straightforward to put together. It's a probably a good second or third kit for a youngster. And yeah, the board is not highest quality, but again, it's just a learning kit, so that's okay. And went together pretty quick. And I hope you enjoyed the video.